Hello everyone. Let's start with the third criteria air pollutant, that is nitrogen dioxide, along with the other oxides of nitrogen. So oxides of nitrogen. There are about 7 different oxides of nitrogen, which are nitric oxide, nitrogen dioxide, nitrate, nitrous oxide, dinitrogen, trioxide, dinitrogen, tetraoxide, then dinitrogen and pentaoxide. So these are the oxides of nitrogen which are known to exist in the natural system. So although there are 7 oxides of nitrogen, but only 2 are the important air pollutants. Only 2 are the important air pollutants, which are nitrogen dioxide and nitric oxide. So out of 7 oxides of nitrogen which are known to exist, only 2, nitrogen dioxide and nitric oxide, are the important air pollutant. And we have also the nitrous oxide, and this is the greenhouse gas. So out of 7 oxides of nitrogen, we have 2 important air pollutants, that is nitrogen dioxide and nitric oxide, and a greenhouse gas, which is nitrous oxide. So together these nitrogen dioxide and nitrogen dioxide and nitric oxide are called as NOx. So there are different sources of these oxides of nitrogen, that is NOx. So what are the sources of these oxides of nitrogen? The sources are both natural as well as anthropogenic. In the natural sources, we have the lightning, as a major source. Lightning as a major source. However, in the anthropogenic anthropogenic sources, it is the combustion of fossil fuels. Which is further divided into the emission of thermal NOx and fuel NOx. So during the anthropogenic process, or during the process of combustion of fossil fuel, there are the emission of thermal NOx and the fuel NOx. However, in the natural process, lightning is the major source of these oxides of nitrogen. So at the very first, we will start with the natural process of oxides of nitrogen. So we will start with the what are the natural sources of nitrogen? That is, we have the lightning. Lightning is the natural source of nitrogen dioxide in the atmosphere. During the lightning, high temperature and intense heat high temperature and intense heat may cause the dissociation of nitrogen and oxygen into atomic nitrogen and oxygen. As we know that nitrogen and oxygen are the main constituents of the air. So during the lightning processes, this nitrogen and oxygen will be dissociated into atomic nitrogen and oxygen atoms. At the high temperature of about 25,000 Kelvin to 30,000 Kelvin. So during these processes, the nitrogen which is already present in the atmosphere at the temperature of 20,000 degrees Celsius will thermally dissociate into atomic nitrogen, and then the oxygen is also dissociated into oxygen atoms at high temperature and intense heat in the lightning process. So this nitrogen which is already present in the air will combine with the atomic oxygen, leads to the formation of NO, which is nitric oxide, and nitrogen. Further, this atomic nitrogen will also react with oxygen and form NO plus oxygen. So the formation of NO, when the formation of NO, that is nitric oxide, is taken place, this will again combine with the oxygen and leads to the formation of nitrogen dioxide. So this process of oxidation of nitrogen and oxygen is also known as Zeldovich mechanism. So this process of oxidation of nitrogen and oxygen to the formation of nitrogen oxides such as NO, and then finally the nitrogen dioxide, is also called as Zeldovich mechanism. And this lightning processes, the natural process of lightning leads to the formation of about 10 to 15% of NOx. So basically the lightning process has a contribution of about 10 to 15% of NOx in the atmosphere. So this was about the lightning processes and the formation of oxides of nitrogen in the atmosphere. Now the anthropogenic sources of NOx in the atmosphere. Combustion of fuel is the major contributor to the NOx in the atmosphere. The two primary sources of NOx in the combustion process are thermal NOx and the fuel NOx. So basically in the anthropogenic sources of NOx, we have the combustion process. So in combustion, we have thermal NOx and the fuel NOx. So where do this thermal NOx come from? Thermal NOx is produced during high temperature combustion process such as power plants, industrial furnace and internal combustion engines. Thermal NOx forms when nitrogen and oxygen molecules in the air react at high temperature, typically above 1200 degrees Celsius. So, what happens in the power plants, industrial furnace and internal combustion engine? As we know that air contains nitrogen up to 78% and oxygen up to 21%. So in a internal combustion engine, जैसे कि किसी इंटरनल कंबशन इंजन की बात करें, किसी भी कार के इंटरनल कंबशन इंजन की बात करें, उसमें हमें कंबशन प्रोसेस के लिए एयर टू फ्यूल रेशियो रखना होता है, एयर टू फ्यूल रेशियो. सो एयर टू फ्यूल रेशियो में हमें फ्यूल तो सप्लाई करनी होती है, along with that we have to supply the air. So internal combustion engine में combustion process के लिए we have to supply fuel plus air in a proper air to fuel ratio. So if we supply the air to the internal combustion engine, as which is already happening in the internal combustion engine, this air contains nitrogen and oxygen. So when there is a high temperature in the internal combustion engine of up to 1200 degrees Celsius, these nitrogen will split into atomic nitrogen and oxygen will split into atomic oxygen. So these nitrogen and oxygen molecule will be converted into atomic nitrogen and atomic oxygens in the internal combustion engine at the temperature of around 1200 डिग्री सेल्सियस. सो इस टेम्परेचर पे नाइट्रोजन और ऑक्सीजन जो मॉलिक्यूल्स हैं जो हमें एयर से सप्लाई हुए हैं इन combustion engines में, तो these nitrogen and oxygen molecule will split into atomic nitrogen and oxygen. These nitrogen now this nitrogen, which is atomic nitrogen, will combine with oxygen to form the NO plus O, and if we have the oxygen, atomic oxygen, it will react with the nitrogen and form NO plus N. So we have the emission of NO, nitric oxide. So if we have the nitric oxide, this nitric oxide will react with oxygen again to give NO2. So this is the process of formation of NOx in the internal combustion engines in the form of thermal NOx. So thermal NOx is basically the formation of NOx due to the high heat. Thermal means high temperature and heat in the engine. So this high temperature of 1200 degrees Celsius will lead to the splitting of nitrogen into nitrogen, atomic nitrogen, and these atomic oxygens, these will combine with again to form NO. So NO formed will react, NO will react with oxygen and give 2 times NO2. So we have the formation of nitrogen dioxide in this process. So this process is called as thermal NOx. Now we have the second process, which is called fuel NOx. Fuel NOx result from the oxidation of nitrogen compound chemically bound in the fuel molecule themselves. So as we have seen that in the thermal NOx we had the nitrogen from the air, but in the fuel NOx we have the nitrogen from the fuel molecule. अगर हमारे फ्यूल मॉलिक्यूल में नाइट्रोजन है, that nitrogen will lead to the formation of NOx. So both thermal NOx and fuel NOx can be significant contributor to emission, but fuel NOx is 95% is often dominant. So it is said that fuel NOx is always higher contributor as compared to thermal NOx. So fuel NOx is always higher contributor to the NOx emission into the atmosphere as compared to thermal NOx. So about 95% of the anthropogenic emission of NOx is in the form of NO, which is a colorless gas that has no known adverse health effect. Now 95% जो हमारे पास emission होती है anthropogenic NOx की, that is at the first stage is in the form of NO, nitric oxide. So nitric oxide basically is a colorless gas and has no known adverse effect, but this NO formed at the first stage of NOx emission will readily oxidize to form NO2. ये तो इसके तो कोई हेल्थ इफेक्ट नहीं थे, एडवर्स हेल्थ इफेक्ट नहीं थे, बट दिस इज वेरी रिएक्टिव. It react very quickly and get oxidized to form the NO2. तो ये जल्दी ऑक्सीडाइज होके NO2 बना लेता है. So therefore the NO2 formed can irritate the lungs, cause bronchitis and pneumonia, and lower resistance to respiratory infection. Right? So at the first stage NO is formed, which is basically not having any adverse effect, but this NO get readily oxidized and form NO2, which is nitrogen dioxide. So nitrogen dioxide is an irritant and has different effects such as bronchitis, pneumonia and lower resistance to respiratory infection. So the most important role of NOx is the formation of secondary pollutants like pain, which is basically peroxyacetyl nitrate and tropospheric ozone and even aldehydes. So NOx, if formed and emitted into the atmosphere, it will lead to other photochemical reactions and forms the pain, which is the component of basically smog. It will also result in the formation of ozone in the atmosphere and aldehydes. Right? So nitrogen dioxide, if present in the atmosphere at high concentration, it is responsible for the reddish brown color in the smoke that hovers over the cities, like as was observed in the Los Angeles in 1944. So a reddish brown color to the smog in the atmosphere is due to nitrogen dioxide. If the atmospheric haze अगर आप देखोगे कभी भी एटमॉस्फेयर में जो हेज़ है ना, हाई पोल्यूशन है, हेज़ है, उसका कलर ब्राउन है, तो यू कैन गेस दैट दिस इज़ ड्यू टू दी नाइट्रोजन डाइऑक्साइड. सो इसका मतलब यह है कि एटमॉस्फेयर में नाइट्रोजन डाइऑक्साइड की एमिशन काफ़ी ज़्यादा हो चुकी है. सो similar to the other pollutants, as we have discussed, NOx has the nitrogen dioxide has its national ambient air quality standards. NOx के लिए भी सेंट्रल पोल्यूशन कंट्रोल बोर्ड ने कुछ स्टैंडर्ड्स सेट करके रखे हुए हैं. सो व्हाट आर दीज नेक्स्ट फॉर नेशनल एम्बिएंट एयर क्वालिटी स्टैंडर्ड्स फॉर NOx? The annual standard is basically 40 microgram per cubic meter. In 24-hour standard is basically 80 microgram per cubic meter. So that means on an average of 24 hours, in a 24-hour, the average of NOx, NO2, nitrogen dioxide concentration in the atmosphere should not exceed the 80 microgram per cubic meter. However, for an annual average, the concentration of NO2 in the atmosphere should not increase or exceed above 40 microgram per cubic meter. So these are the standards of NOx prescribed by Central Pollution Control Board. So what is the role of NOx in ozone formation? As we have already discussed in the video of ozone, that if we have NO2, nitrogen dioxide, in the atmosphere, these are basically the basic reactions that leads to the formation of NO2. Now if we have NO2 in the atmosphere, this NO2 will photo dissociate in the presence of solar radiation, leads to the formation of NO plus oxygen atom. This oxygen atom so formed will react, oxygen atom will react with oxygen molecule in an external, in the presence of an external body, will form the ozone. So this is how the ozone is formed, and this is what the role of NOx, then NO and NO2, role of NOx in the formation of ozone. NOx, oxides of nitrogen, also plays significant role in the formation of photochemical smog, that is pain and acid rain. So NOx also play significant role in acid rain formation and also in photochemical smog formation, in which major ingredient was the pain, peroxyacetyl nitrate. So I think this is it for the oxides of nitrogen.